Find the derivative of each function. All of these three functions are in log form. Keep in mind that the derivative of ln of x is 1 over x, but the derivative of log base b of x is 1 over x times ln of b, where ln of b is in the denominator. This means if the base is not e, remember that ln is log base e. If the base is not e, we need ln of b. Remember that ln of e is 1. For the first problem, h of x equals ln of 4x minus 2 raised to the 1/3 power. When we have log, ln is log, it is much better to rewrite it if we have a power or a product or a quotient inside of log. In this case, we would rewrite this h of x, not h prime, but the original function h of x as we move the power to the front of ln to get 1.3 times ln of 4x minus 2. Then this 1.3 is now a constant multiple. Before it was a power of the inside function. Then we observe that inside of this ln, which is log, there is another function. There is a function inside another function, so we would need to use the chain rule. That inside function, we let it be u equals 4x minus 2. Its derivative du dx is 4. The derivative of 4x is 4, and the derivative of negative 2 is 0. The problem, if we were to let u equals 4x minus 2, then the problem is now simplifying to ln of u, but remember that we have 1.3 in front of ln. The derivative of 1.3 ln of u with respect to x is 1.3 over u, but don't forget the chain rule, du dx. Putting these together, we have h prime of x equals 1.3 over u, but u is 4x minus 2, times du dx. Du dx is 4. 4 times 1.3 is 5.2. And so the derivative is 5.2 over 4x minus 2. For the second part, realizing that there is a function x squared plus x inside log base 3 function, so we will let u be x squared plus x. Then du dx, the derivative of u, is 2x plus 1. We now need to find the derivative of log base 3 of u, which is 1 over u times ln of 3, where ln of 3 is in the denominator because this is log, not base e. And then we would multiply du dx. This is 1 over u is x squared plus x. And then we still need ln of 3 in the denominator times du dx, but du dx is 2x plus 1. And so the answer is 2x plus 1 over x squared plus x times ln of 3. And again, ln of 3 is in the denominator. Lastly, for n of x, the inside function is a quotient. However, we will avoid working with the quotient rule if we rewrite n of x using the logarithmic property. The log of a quotient is the difference of the logs. And so this is log base 2 of 3x plus 1 minus log base 2 of 4x minus 2. We will need to use the chain rule for each of the terms. The derivative n prime of x is now 1 over 3x plus 1 times ln of 2 times the derivative of the inside function. The derivative of 3x plus 1 is 3 minus the derivative of log base 2 of u is 1 over u, where u is the inside function, and this is not base e, so we would need to multiply ln of the base, and then we multiply the derivative of the inside, but the derivative of 4x minus 2 is 4. And so we rewrite this as 3 over 3x plus 1 times ln of 2, where ln of 2 is in the denominator, minus 4 over 4x minus 2 times ln of 2, where again ln of 2 is in the denominator.